Dear student, welcome to this lecture on textile testing. In this lecture, I am going to discuss the bursting strength testing. Earlier, I have discussed tensile strength and tearing strength, but bursting strength is something different from either of these two. Now, in this lecture, I will cover what is the meaning of the bursting strength, then what is the scope of application of bursting strength, then type of bursting test, and measurement procedure of bursting strength of a fabric, and we will discuss the principle and the working procedure. So let us first see what is the meaning of the term bursting strength. As I have already told you, I have discussed tensile strength and the tearing strength. Now, if you can recall, in both the testing, the direction of application of force are either along the direction of the axis or along the direction of tear. As for example, in the case of tensile testing, we are applying the force along the axis of the fabric. It may be along the wall or it may be along the bed. In case of the tearing strength, we are applying the force in the direction of tear. But in the case of the bursting strength, we will apply the force in all directions. And this type of force we know that is known as the distending force. So let us first see what is the meaning of this word bursting strength. Now, bursting strength can be defined as the maximum value of the distending force acting normally and simultaneously in all directions that a specimen can sustain before it fails. Now, note this word. This is a very important word. What is the meaning of the word distending force? Distending force should have certain criteria. It should always act from the inside and it cause swelling, right? And you can say it is always acting normally and simultaneously in all directions. So this tending force has got four characteristics. Usually it is acting from the inside, it causes the swelling, and it acts simultaneously in all directions and acts normally. Now, best possible example of the bursting, the distending force is you can consider the case of a balloon. When the balloon is deflated condition, and now you blow air inside it, you will find that the balloon will swell, or you can say balloon will inflate. In this case, the air which is inside the balloon, which will act normally in all possible direction and causing the swelling of the balloon, right? So this, you can say, the example I am giving here, exactly this is the case in the bursting strength. So this is the fabric. If you can say this is the fabric, and in this direction the pressure is applied. How the pressure is applied, how the fabric is mounted, that I am going to discuss in the test procedure. Okay, but here you can see, here the fabric is in the, after application of the distending force, the fabric swells. Okay, right? And this is the diaphragm, and the pressure is always acting in from inside, and because of this pressure, there is swelling of the fabric. Okay, now this is very important point. When a fabric is subjected to bursting strength, the fabric undergoes same extension in all possible directions. So the fabric will fail first in the direction with the lowest extension and break. This is not necessarily the direction with the lowest strength. Now remember, when you apply the distending force, the fabric will extend in all possible direction, and the fabric will fail, or the fabric will rupture in the direction where the extension at break is low. Okay, it is not the uh, always the strength that is important. That means if the extension of the fabric is low in a particular direction, that cannot sustain the extension to that extent, it will break. Okay. Now let us see the what is the application of the bursting strength, or you can say for which category of the fabric bursting strength is important. Now bursting strength is important the type of fabric where the force is applied in all possible directions. As for example, you can say it is a parachute fabric, it is a filters, sacks, nets, knitted fabric, and also the paper used for the wrapping and packaging fabric. Now, most of the cases, the fabric which is used for the packaging purpose and as well as the fabric which is to be used in the parachute fabric, the bursting strength is very much important because in both the cases, the force acting in all directions, and that's true simultaneously. And also remember, in the case of the knitting fabric, the tensile strength is not applicable. Here we have to calculate the bursting strength. The fabric is more likely to fail by bursting the surface than it is to break by a straight tensile fracture, as in the case of the portion of the fabric in the elbows and the knees. You might have come across the situation that due to excessive uses of the fabric, the portion of the fabric which is near the elbow or the knee will always burst first. And it is because of the bursting force that is exerted during the movement of the elbow or knee of the part of the fabric. Now, there are two types of bursting strength. One is the diaphragm bursting strength, another is the ball bursting strength. Both are in use, but diaphragm bursting strength is more popular, but it has got certain disadvantage that I will discuss afterwards. So I will discuss both type of bursting strength testing, and first I am going to discuss the diaphragm bursting strength test. Now, in the case of diaphragm bursting strength testing, the fabric is subjected to a distended force, as I have already mentioned earlier. The fabric is mounted on the diaphragm and it is subjected to a bursting force. And the bursting force is then measured till it fails, and suppose this bursting strength is B. Okay, now that means what I mean to say here, the fabric is placed on the diaphragm and a bursting force is applied, and because of this bursting force, the specimen fails and left the pressure is B. The force needed to inflate the diaphragm is to be taken into consideration. Now, what are the force that we have applied? It will be utilized in two ways. The first, it will cause extension, or you can say the inflation of the diaphragm. You cannot say the word extension here because extension is always taking place in particular direction. The more appropriate word is inflation. So here the diaphragm will inflate, and secondly, it will also cause the specimen to break. That means the force applied at the time of bursting strength testing will be utilized in two ways. The first one to inflate the diaphragm, and second one is to break the specimen. Now we have to deduct what is the force needed to inflate the specimen. For this purpose, what we have to do, we have to measure the force which is needed to inflate the specimen to that extent. That means here we have to repeat the same test. It is known as the blank test, but without the fabric placed at the clamp. That means bursting strength here is given by S is equal to B minus T. What is the B? B is the bursting strength noted with the fabric, and T is the bursting strength. T is the TR pressure. It is noted when there is no fabric. See, the principle of bursting strength testing will be clear from this diagram. See, this is This is the diaphragm. This is the diaphragm. Okay, and a pressure is applied from inside. This yellow color you might have seen. This is the fabric. Now, initially, the diaphragm will be in the horizontal position, or diaphragm will be initially in this position. Now, when you apply the pressure, what will happen? There will be inflation of this diaphragm, inflation of this diaphragm. As a result, what will happen? The fabric will distend gradually, and after a certain time, it will break. Okay, let us consider the force needed at this force noted is B. Okay, now perform the similar test without this fabric. This is known as the blank test, and what are the pressure or force that we have noted? That is known as the tear pressure. That means you can see very well that there is no fabric that is present over here. There is no fabric is present here. That means in this case the force required is to inflate the inflate this diaphragm. But in this case, the pressure that is applied is utilized in two ways. First, to inflate the diaphragm, as well as to inflate the or cause the bursting of this fabric. Okay, so if you deduct the T from B, so what it will be left? That is the what is the force required to burst the fabric, because the force required to inflate the diaphragm will be cancelled out from each other. Now, this is the schematic diagram of a bursting strength tester. This is composed of a container or vessel, and which is filled with liquid or gas. There are two types. One may be the hydraulic, another one is the pneumatic. In case of the pneumatic, it is filled with air, and in the case of the hydraulic, it is filled with either water or mostly in case of glycerin. So this is the piston. This piston can move in this direction, along this direction. The piston can move in this direction. So when the piston is moving in this direction, what will happen? The air inside this container, or the liquid or the fluid, whatever it is, this fluid will undergo compression. As a result of compression, what will happen? You can say the pressure will be acting on this diaphragm as well as onto this fabric. So this black color, this is the diaphragm and this is the fabric, and these are the clamp. Okay, and this is the pressure gauge. So whenever there is a failure of the fabric, you can note the pressure from here. So again I am telling, let us see what are the major component of this bursting strength tester. First is the diaphragm. So this black color, this is the diaphragm. This diaphragm is made of synthetic molded rubber, and the size of the diaphragm is 48 millimeter. The size of the specimen, see, this is the specimen. The specimen size is 30 millimeter in diameter. These are the clamps. So these are the clamps. These clamps are made by a stainless steel annular ring. This is the pressure gauge. This is the pressure gauge, and you have to ensure that the individual reading for the bursting strength of the fabric should be fall within 25% to 75% of the total capacity of this. Okay, now this is the liquid, and generally the glycerin is used in the case of the hydraulic bursting strength tester. In the case of pneumatic, it is the air. So this is the piston. This piston can be moved by means of a screw mechanism. Okay, it can be moved by means of a wheel, or it can be operated electrically, right? Now this is the measurement process. As I have already told you, see, you can see from here that this is the instrument, this is the piston, this is the pressure gauge, and this is the initial position. This is the initial stage of the carrying out the testing. So fabric is mounted on the diaphragm. Okay, the specimen is 30 millimeter, and the disc is generally half inch greater than that of the clamp ring. Now 10 specimen are to be used for this purpose. Okay. Now the specimen is placed over this diaphragm. Okay, this specimen is to be placed diaphragm, and the specimen should be clamped very tightly so that there is no slippage of the fabric takes place. Now switch on the machine. When the machine is switched on, then what will happen? The piston will start moving in this direction. When the piston moves in this direction, then what will happen? The pressure inside this container will build up. Okay, and this pressure inside this container will cause the inflation of this diaphragm as well as the fabric. Now, if you continue to increase the pressure, the time will come when the fabric cannot sustain the force, and thereafter it will fail. Okay. Now, when the fabric fail because of this thrusting force, you have to note the reading. Suppose I am considering this reading is P1. Now also you have to note what is the extension of this diaphragm. Now you have to repeat another test. Okay, why you have to repeat the another test? Because now you have to deduct what is the force needed to inflate the diaphragm. Now you remove the fabric from the diaphragm and repeat the test. Okay, and in this time, suppose the pressure noted is P2. Okay, now subtract P2 from P1, and this will give you the actual bursting strength of the specimen. Okay, now there are certain limitations of the diaphragm bursting strength. First of all, blank test is required, and blank test needs to be calculated very accurately, because earlier, first you have to carry out the test, and the force that is noted is sum of two things. First one, the force required to break the specimen, and secondly, force required to inflate the diaphragm. But we have to deduct what is the force needed to inflate the diaphragm. For this purpose, we have to repeat the blank test, wherein we have to determine what is the force necessary to inflate the diaphragm to that extent. So result of the blank test should be subtracted from the first test. Next, because of the movement of the piston, there may be chance of spilling of the liquid, and the diaphragm needs to be changed, because diaphragm is basically one sort of elastic rubber. So after repeated use, its elasticity may be changed. Now the crimp percentage in the warp and wave played an important role. For similar year, the direction of the lower crimp percentage will break. Okay. Now the disadvantage of diaphragm test bursting strength is that limit to extension that can be given to the sample when to the fact that rubber diaphragm has to stretch the same amount. This I have already told you, because this is the limitation of the diaphragm testing, because you have to inflate the diaphragm to that heavy extent, and this is not suitable for the knitted fabric. And now especially knitted fabric which have very high extension. So ordinary knitted fabric can be tested with this type of instrument, but if the knitted fabric has got very high extensibility, then this type of instrument may give erroneous results. So for that purpose, we have to use the ball bursting strength test. So let us see what is the scope of application of ball bursting strength. The fabrics having more extension that cannot be checked by diaphragm bursting strength can be checked by this method. That I have already told, especially in the case of the knitted fabric, which have got very high extensibility. This test can be carried out in a standard universal strength tester with a suitable attachment. This is one advantage. That means the ball bursting strength instrument is not a separate instrument. You just need an attachment. This attachment can be fitted onto the universal strength testing working on CRD principle, and that will become the ball bursting strength instrument. Okay. Apart from the knitted fabric, you can calculate the ball by ball bursting strength instrument, the non-woven fabric, coated fabric, etc. Now, here what is the principle? You can see from this instrument. See, this is the ball. Actually, what you have to do, you have to measure the bursting strength by forcing a steel ball through the fabric. See, this is the steel ball. Okay, this test can be carried out using an attachment on the standard tensile testing device working on CRD principle that I have told you. That means this can be carried out in a CRD instrument, provided you have got a special type of attachment. This type of attachment that I have shown here, I will describe it afterwards. The center portion of the pushes it against the steel ball in constant rate until it ruptures. The ball bursting strength can be calculated from the force of rupture F and the internal cross-sectional area A of the test piece. That means, in that case, the ball bursting strength will give the strength of the unit in terms of pressure. That means force per unit area. So this is the device, or you can say this is the attachment which needs to be incorporated in the ball bursting strength tester. So this is the clamp. You can see this is the circular stainless steel clamp. This is a shaft, and then below the shaft there is a ball. This is the ball. Now what we have to do, see, this shaft will act just like a plunger. See, you can see this is the plunger, this is the ball, this is the clamp, and between this clamp the fabric is tightly gripped. Again, also we have to take very that there is no slippage between the fabric and the clamp. So this is the fabric, white color. This you can see this is the fabric. This is the clamp. Now this is the grip distribution of the machine that you can see. The steel diameter of the steel ball that I have shown you, that is around 1 inch. The clamp diameter is 1.75 inch. The speed of the ball is 12 inch per minute, or you can say 300 millimeter per minute. The clamping device has an upper and a lower clamp with the concentric grooves and crowns that intermesh with the test piece to provide the grip. Why this type of grip design is? Because I have told you that you have to prevent the slippage of the fabric. To prevent the slippage of the fabric, the clamp should be built in such a design that it will not allow to slip the fabric at the time of testing. The test specimen can be cut into square or circular around the complete circumference of the total clamp. The face of the ring should be perpendicular to the direction of the application of the force. That I will show in the next slide. In the it will be clear. The center portion of the pushes against a polished steel ball at a constant rate, because I have told you that the instrument should be working on constant rate of extension, and this we have to continue until it ruptures. So this is a constant rate of extension. Okay, this is the console from where you can get the reading, and the lower part, it is magnified here. This is the clamp. I have shown you. This is the clamp separate in a magnified view. This is the ball. This is the ball, and this is the plunger. Okay, the fabric is pushed against this ball, and it should be continued till the fabric ruptures. See, this is the fabric, and the fabric is ruptured because of the force created by the constant moving of this ball inside the against the fabric. Okay. Now you can say these are the advantage of ball bursting strength tester over the diaphragm tester. The errors due to diaphragm expansion is absent in the ball bursting instrument, because in the case of the ball bursting instrument there is no use of the diaphragm. So error whichever is encountered during the extension of the diaphragm is not present. The ball bursting test can be performed using an attachment of the standard tensile testing machine. This I have mentioned earlier, that ball bursting strength tester, you need not to have a different machine, rather you have to have an attachment. This attachment can be fitted onto this CRE equipment, and that will become a ball bursting strength tester. In the diaphragm, bursting strain pressure is measured, but here force is measured. Okay. The fabric having the more extension, sorry, actually remember one thing, that in case of the diagram, in case of ball bursting, you have to give the force per unit area. Okay. So in the pressure unit is there. The ball bursting strain can be carried out on a standard universal strain tester with a suitable attachment. And this method is suitable for knitted fabric like woven fabric and coated fabric. So this is all about your ball bursting strength. So what I mean to say here, again I am repeating, that bursting strength is different from the tensile as well as the tearing strength. Why it is different? Because in the case of the tensile strength, the force is applied along the direction of axis of the fabric, might be in the direction of the rod or direction of the weight. But in the case of, similarly in the case of the tearing strength, the force is applied along the direction of the tear. But in the case of the bursting strength, the force is of descending in nature. That means the force always acts perpendicular in all possible directions at the same time. And the bursting strength is basically suitable for those fabric which are used for packaging purpose, and also it is suitable for knitted fabric. Right? Now there are two types of bursting strength. One is the diaphragm bursting strength, and the other one is the ball bursting strength. Now, though diaphragm bursting strength has got certain disadvantages, but it is more popular. Okay, but you cannot measure the bursting strength for a fabric having, or rather bursting strength for a knitted fabric having high extension. Okay, so this is all about your bursting strength. In the next lecture, we will seam strength of the fabric. Okay.